This video is a continuation of the previous video of solving absolute value inequalities. Now, in these examples, we're going to see a little more complex work to do. So, for example, what we need to make sure is that we need to make sure the absolute value is isolated on the left-hand side in order to determine whether we're dealing with a disjunction or a conjunction. In order to isolate the absolute value here, we have 2 times the absolute value. Now, it seems tempting to want to distribute. We're used to distributing when we see grouping symbols next to a number, but that's actually not what we do here. That is mathematically incorrect. Instead, we can treat the absolute value bars temporarily as though that expression is just a single variable. So it's kind of going to mirror 2y is greater than or equal to 16. And if we were going to get y by itself, what would we do? We would divide both sides by 2. That's the same thing that we want to do in letter E. We're going to divide both sides by 2. The 2's will cancel, leaving us with the absolute value. I don't know why that happens. Okay. Of negative 5x minus 3 is greater than or equal to 16 divided by 2 is 8. Now that the absolute value is isolated, we can decide, since this is a greater than, we are talking about a disjunction. We're talking about things that are bigger than or equal to 8, or things that are less than or equal to negative 8. So this is an or situation, meaning we have 2 cases. Case 1, we would have negative 5x minus 3 is greater than or equal to 8. And case 2 would be negative 5x minus 3 is less than or equal to negative 8. As always, notice what's inside the absolute value bars stays the same. The symbol changes, and then the sign of the right-hand side changes too. Okay, from here, we're going to get x by itself. So I'm going to add 3 to both sides. This gives me negative 5x is greater than or equal to 11. And then I'm going to divide both sides by negative 5. Now I'm dividing both sides by a negative, and this is an inequality. So I need to flip the inequality symbol around. So this is going to give me, I'm going to put it over here because I don't want to go too low on the screen, x is less than or equal to negative 11/5. If you'd rather think about that as a mixed number, you can. That would be negative 2 1/5. If you want to write that as a decimal, that would be negative 2.2. Any of those 3 are fine. For case 2, we're going to add 3 to both sides. That's going to give me negative 5x is less than or equal to negative 5. Divide both sides by negative 5, and again, I'm dividing by a negative, so that inequality symbol is going to flip around. Negative 5 divided by negative 5 is positive 1. So here's the first part of the solution. X is less than or equal to negative 11/5 or negative 2 1/5. Or x is greater than or equal to 1. Now on my number line, I'm going to use integers, so I'm just going to know that negative 2 1/5 lies between negative 3 and negative 2, closer to negative 2. So we'll start negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3. And that's going to be a closed circle over negative 2 1/5. I don't know why it keeps going up like that. It's weird. Okay, and the arrow is going to the left. And we're going to do a closed circle over 1, and the arrow is going to go to the right. So all of the solutions are either here, smaller than negative 2 1/5, or here, bigger than or equal to 1. In interval notation, this is a disjunction, so we have 2 separate intervals. The first interval is going to be represented here. It's the range from negative infinity to negative 2 1/5. Negative 2 1/5 is included, so I use the bracket, or, and then I open up with a bracket, 1 to infinity. And that would be the final solution for letter E. For letter F, I notice that the absolute value is being added by 4, so before I can consider my 2 cases, I need to subtract 4 from both sides, and it's really important that you do this. A very common mistake is I have students who set up the 2 cases with that plus 4 there, and then they don't change the sign of the plus 4, which then makes the entire thing wrong. So we want to be really careful about that. We don't look at the cases until the absolute value bars are isolated. So we have absolute value of 1/2 a minus 2 is less than or equal to, I think my pen has gone insane, it is less than or equal to 3. There we go. And don't panic that there's a fraction here. I know in the past that I've talked about being able to get rid of fractions when we're talking about absolute equations and inequalities, but unfortunately we can't do that here because it is stuck inside the absolute value. The good news is that 1/2 is actually the world's nicest fraction. and we don't need to panic about it. We don't need to stress about it. We can just deal with that when the time comes. So we have the absolute value isolated. We're ready to consider the fact that this is a conjunction, meaning that any solution must meet two criteria. It's going to have to be bigger than some smallest point and smaller than some biggest point. The way we set up our conjunctions, since the range is going to be ending at 3, that means that the beginning of this range is -3. So it's going to be -3 is less than or equal to 1/2 times a minus 2, which will be less than or equal to 3. Now we want to get a isolated in the middle. So first I'm going to add 2 to the 3 parts, the left, the middle, which I already did, and the right. -3 plus 2 is -1, so we have -1 is less than or equal to 1/2 times a, which is less than or equal to 5. Now to get a by itself, so because it's being multiplied, you might say, well, we need to divide everything by 1/2. And well, technically that's true. Yes, we do. Maybe a simpler option would be to say, okay, if a variable is being multiplied by a fraction, we can multiply by its reciprocal, and that will cancel out that fraction where we need it to cancel. So the reciprocal of 1/2 is 2. So we're going to multiply the middle by 2, the left by 2, and the right by 2. That's going to give us -2 is less than or equal to a is less than or equal to 10. Close that parenthesis. Now we have the inequality set up, the compound inequality. Yay. Next we need to graph. So since my 2 endpoints are both even, we all know that I'm going to only write the even numbers. I'm probably going to skip every other number just so that it's not so squished. So we'll have -4, -2, 0, 2, 4, 6, 8, 10, 12. -2 would be right here, and it's going to be a closed circle since it is included. Hello. And over 10 will also be a closed circle because 10 is part of the solution as well. And we connect it with a nice straight bar. So that indicates that all of the solutions lie between -2 and +10. In interval notation, it's going to be bracket, -2, comma, 10, bracket. In this example, letter G, we have -10 is greater than -3 times the absolute value of -3x minus 5 plus 2. Okay, there's a lot of issues with this one, but the first thing that I noticed is that the absolute value is on the wrong side. We most commonly want it on the left because that helps us identify whether it's a conjunction or a disjunction. That's not to say it's impossible to leave it on the right, but it does make it a little more difficult. So when we switch this around, inequalities are not commutative, meaning I cannot just switch the two sides and call it good. I also have to make sure that this symbol, it's opening up towards -10, it needs to remain opening up towards -10. So when I switch the two sides, I need to also switch the inequality symbol. So I'm going to rewrite it. The left is now going to be the -3 times the absolute value of -3x minus 5 plus 2. So the entire right-hand side is now the left-hand side. I need to switch the inequality symbol around, is less than -10. Okay, I feel better. Absolute value is on the left. Now we have a few things happening to it. It's being multiplied by something and it's being added to something. First, we're going to undo the addition. So we're going to subtract 2 from both sides. That will leave me with -3 times the absolute value of -3x minus 5 is less than -12. Now remember, I cannot distribute the -3. It is mathematically incorrect to do so. You will not have the right answer if you do this. So what we need to do instead is we need to divide both sides by -3. When we divide both sides by -3, what's that going to do to our inequality? It's going to flip it around, right? We divided both sides by a negative. This goes back to being greater than. So we're back where we started. So now we have the absolute value of -3x minus 5 is greater than 4. The absolute value is by itself on the left-hand side, and it is greater than something, indicating that we have a disjunction, an OR situation. So we have two cases to consider. Case 1 is when -3x minus 5 is greater than 4, and case 2 is when -3x minus 5 is less than -4. We're going to solve for x in each case, so I'm going to add 5 to both sides. That's going to give me -3x is greater than 9. Now I'm going to divide both sides by -3. I'm dividing by a negative. So one more time, in case you haven't had enough of flipping the inequality around, we're going to flip it around again, giving us x is less than -3. For the second inequality, we're going to add 5 to both sides. And we'll have negative 3x is less than 1. We're going to ignore that line that just randomly appeared. To get x by itself, we're going to divide both sides by negative 3. And when we divide by a negative, we need to flip the inequality around. So this becomes greater than negative 1/3. This was an or situation, so there are the two cases. X can be less than negative 3, or x can be greater than negative 1/3. On my graph, I'm going to use integers. So I'm going to place negative 1/3. It's going to be between 0 and negative 1, and it's going to be a little bit closer to 0. So I'm going to put my tick marks. We're going to pretend like they're evenly spaced. Negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2. Negative 3 will have an open circle since negative 3 is not part of the solution set, arrow going to the left. Negative 1/3 is going to be right there approximately with the arrow going to the right. And again, we're going to ignore that random line that just randomly appeared. In interval notation, to represent x is less than negative 3, we would say that's negative infinity to negative 3. And we don't include negative 3, so we use a parenthesis, or negative 1/3 to infinity. All right, and the next slide is our last example. Here in letter H, I see that the absolute value is not yet isolated. The good news is that it is on the left-hand side, so let's subtract 3 from both sides. Now I have the absolute value of 2a minus 8 is less than or equal to negative 14. There's that line again. Let's see. 14. There we go. Now, I'm saying that an absolute value, that's something that is non-negative. So the minimum that an absolute value can be is 0. I am saying that this particular thing is going to be less than or equal to negative 14. That is impossible. There's no way we can take the absolute value of something and its value is less than or equal to negative 14. We're talking about a special case here. Notice it's special because we have the absolute value isolated and it is less than something negative. The important thing is that there's a negative on the right-hand side, which is unusual, meaning either it's going to be everything or nothing. And in this case, it's nothing. There's nothing we can take the absolute value of that will be less than or equal to negative 14. So to represent this, we can say, first we're going to say no solution. On a graph, we would just draw a graph. And you can put whatever numbers you want on your graph. It doesn't matter because we're not doing anything. So let's do 65, 66, 67, 68, 69, 70, and 71. And we don't put anything on it. No circles, no arrows. That's it. We're done. I got a little carried away there. Probably we could just do a number line and just have negative 1, 0, and 1. But that's okay. And then to say in interval notation, you have two choices. You can open up a set of braces and then put nothing in it, or you can use the empty set symbol, which is like a 0 with a slash through it. And that is absolute value inequalities.